Hi everyone, welcome to week 10 live session of NPTEL's Digital Circuit course. I am Om and today we will be solving some questions which may help you in your assignments. So let us start. So in this week mainly we will be covering some questions mainly based on microprocessors and typically 8085 and some part of hardware description languages. So let us start. So most of these questions this time are theoretical, so we may finish early today. Okay, so the first question is VHDL and Verilog are A. Software description language, B. Assembly language, C. Hardware description language, D. Machine language. Right, so Harsha, you have given right answer. It is hardware description language. So this HDL and VHDL itself stands for hardware description language. And what are hardware description language? So hardware description languages are basically some specialized computer language which describes the behavior of some circuits, right? And it is used by some programs to generate to synthesize uh, some structural logic based on uh, some input language where we have described the behavior of a circuit. So those are hardware description languages. So mostly in this course, the focus has been on VHDL. Verilog has not been talked about, but again, Verilog is a very popular language and is actually used, I think, more than VHDL. So I would advise you guys, if you want to pursue a career in VLSI, to take some courses on Verilog. It will be very helpful for you. So the next question is, what programming languages has been utilized in the development of Verilog HDL? That's right. The correct answer is C programming. So Verilog HDL has been developed using C programming language. Next question. What programming language has been utilized in the development of VHDL? So the answer to this is VHDL is uh, the programming language utilized in development VHDL is ADA language. So you can find this in the this week's first lecture. At the very starting of the course, this has been described. Okay. Next question is, choose the current and correct entity declaration for the following circuit. Okay. So first of all, what is entity? Entity basically describes the input-output configuration of any design that we are trying to build. So what ports are there? Are they input port or output port? What kind of data type do this port support? So that all is defined in the entity. So this whole thing is an entity. So you have rightly said. So option B is correct. Now, what is incorrect in the others? So if you see here, A is input port, B is input port, sum is output port, carry is output port, right? So this is some kind of a design for a half adder maybe, right? Or some adder. So if you see this one, they have written A is input, B is input, but some they have written as input port. This is output. B is the correct one. C also they have made the same mistake. And in D also they have made the same mistake. So the correct answer is B, where A and B are input, sum and carry are output. Okay, next question. Okay, so let us see this question. So here, what they're saying is, what signal should be included in the sensitivity list of the process construct for the given combination of circuit? What is the sensitivity list? Sensitivity list aims looks at uh, is a list of we can say variables which are either used in comparison statements, or are at right hand side of assignment statements. So basically uh, these are the variables which define some other outputs, value of which defines some other outputs. So if you look at a very some very logic of very logic VHDL code uh, of this half adder, what it would look like, we can say is it would be something like first when we define some entity, let's say half adder, and then we define the ports. A is input, let's say bit, B call it V is input bit. Similarly, sum is output bit, carry is output bit, right? Then what we do after, okay, so we end this. We go to the architectural programming and okay, so I'll just write the logic. So inside the process construct, we should have, okay, what we should have that I'll leave it for now, but uh, what will be our main code? When we begin, we know sum is A XOR B. So sum is assigned as A XOR B, and carry is assigned as A and B. Like we end this behavioral block. So if we see on the RHS of these assignments, so we have no comparison statements like if something is greater than or less than, but we have these assignment statements, and these assignment statements on the RHS we have A and B. So A and B will be our in our sensitivity list. So you have answered correctly. I hope this is clear. Okay. So next question. Which of the following statements is true? Okay, so answer to this is option C, not B. So it is asking which is true. Yeah, so this is false. So signals do follow the event of uh, notion of event scheduling, and variables do not follow the notion of event scheduling. Now, what is event scheduling? Event scheduling means, let's say there's some X you are giving to Y. So there could be some signal line between X and Y. So let's say if it starts at time t, at let's say time t plus dt, you'll get this result in y. Whereas in definition of variable, so this is the signal that we define. There is a variable. Variable is just another name for a signals in for some other signals. So x is equal to y. So this means with the no delay, no concept of delay or time, y is just another name for x. So there is no scheduling. This is there is event scheduling in signaling. Is this clear? Okay, I hope this is clear. If not, please you can ask the questions. Okay, let's move on to the next one. Okay, Harsha has asked, do event scheduling is similar to assignments? Uh, okay, so assignment is one way, let's say you can distinguish between a signal and a variable, but what actually it is, so let's say uh, you have some design, say A and B is input, let's say Y is output. Now to describe some behavior, let's say you need another variable uh, S. We call it, let's say, some temporary variable. Now, if you define S using a signal, what it means is like you again have some hardware kind of wiring connection of for S for your uh, design. And generally, we use assignment for it. And but when we use the variables, we directly use this kind of assignment. So both of these are assignments only. But This is generally the way where we define variable, where we say uh, like there is no delay involved. So we can do the assignments between A and Y, and we but those both of those are already in our input and output ports. We can do assignment between S and Y. Now this is between some signal and some port. Let me see if I can find some example that can compare. Okay, so I found some differences. Maybe I can just write here. Signal versus variables. So first is assignment. So in assignment, in signals, we we have some this kind of uh, assignee, assignment, and here it is assignment. Other thing is utility. It represents a circuit interconnect. It represents local storage, behavior, updated at end of process statement. This one is updated immediately. So these are the key differences. Yeah. So yeah, your question was valid. When we use assignments, like for signals, we always use assignments. Okay, so let's go back to the next question. VHDL language is developed by, so right, it is developed by the US Department of Defense. What is logic synthesis? Logic synthesis is a process of, right. Logic synthesis is the process of converting behavior level description to structural level netlist. So we describe the behavior of a circuit and then convert it to some level of structure. Structure means what components could realize this behavior. If I've written out equals is A XOR B and C, that's the sum itself. Carry is A and B. So in the structural level netlist, we are actually making these XOR gates and AND gate. Next one, identify the basic logic block described by the following VHDL code. So B is the correct answer. So basically what this circuit is telling you, you have in a process you are monitoring A, B and S. So you have inputs A, B and S. Your output is Z. So when S is 1, Z is A. When S is 0, Z is B. So basically it should be like this, B and A. Where it would be 0, it would be 1 in a mux. So it is a 2 cross 1 mux. Okay. Maybe we can take one more question on VHDL. We're going to microprocessor. So the question is, mm, what is the circuit described by following VHDL code? So just a minute, I'll give you the code. Okay, so I'll write the code here. If entity, let's call it design phase, then we have architecture, page. Okay, so this is your code. So can anyone tell me what is this circuit? Okay, this is a decoder, correct? What kind of decoder? Yeah, 2x4 decoder, right? So it is clear, like I think reading up VHDL code is pretty straightforward. If you see, you have A in, and A is 2-bit input. So let's say this is A0 and A1. Then you have B is output, that is 4-bit output. B0, B1, B2, B3. And basically, so this part of the code decides your how your design looks like. What are the input output definitions? And now this part of code basically can help you make a truth table out of it. So when you have, let's say, A0, let me write it as A1, A0, B3, B2, B1, B0. Is that correct? Yeah. 0, 0, 0, 1, 1, 0, 1, 1. So if you remember, this is the truth table of a decoder. It is a 2 cross 4 decoder. So I hope this is clear to all. Okay, so now let us move on to the microprocessor part. So mainly we will be talking about some very introductory basics of 8085 microprocessor. So 8085 is Intel's very old microprocessor. So I hope you have seen the video. So can anyone answer this question? Okay, so answer to this is option A, 74 instructions. If you remember in the videos, 8085 is an 8-bit microprocessor, and write it as short form as MUPI. And it has, you can say, 246 different in its, can say in its library. It has 246 different options of what to call it, functions that it can perform. And out of those 246 functions, there are basically 74 instructions that it performs. What are instructions? Let's say I call it A, add B. So what this means? This add is a instruction, and some variations of all these 74 instructions are already stored in these 244, 246 com you can say commands. So basically, this 246 is nothing but some, okay, let's say some binary representation. Some binary representation. So basically, each command is converted into some binary representation, and those binary representations are already stored in this 246 commands. So when we so this conversion between uh, this kind of readable language and these 246 takes place using an assembler, which basically converts this language into these commands that the machine code, or basically binary command which the uh, microprocessor can recognize. Okay, so next question, let's take. Which of the following is not a part of 8085 microprocessor? Yeah, you're right. It should be ALU. CPU is not. Uh, CPU, we can say, is a combination of microprocessor and some other elements. So they should not have written ALU here, CPU here. It should have been ALU. So the answer will be GPU. We have ALU, we have control unit, we have registers, but we do not have what is GPU. Okay. What is the primary function of microprocessor's assembly language? So let D is the correct answer. This, like we already discussed in the previous question, it converts our instructions to some binary or some readable low level form which the machine can read. Okay, next one. Which component is responsible for converting assembly language code into machine code? Right, assembler. Okay, next one. In the context of microprocessor assembly language, what is a mnemonic? So we pronounce this as mnemonic. So if you remember the line lecture, mnemonic is a symbolic code representing an instruction. So let's, as I just said, A add B, or let's say A XOR B or something. So these are all mnemonics. Mnemonics are just some symbolic representations that we can understand, but the hardware will not understand. The hardware will need assembler to convert these, to translate these into a readable language. So it is option C. 8085 microprocessor is a dash bit general purpose processor. All right, 8 bits. So this we have discussed. So why it is called 8-bit processor? Because if you see its registers, all the registers are 8-bit registers. So it can do the uh, operations on only 8-bit numbers, right? If you know uh, the main register near the ALU is accumulator. Whenever you perform an operation in ALU, its output always goes to accumulator. From there, you can copy or paste it anywhere. Whenever you bring, let's say, some data from the memory, so it first goes to ALU, it first goes to accumulator, then from accumulator it can go to ALU. And same thing happens in the output also. Output goes to accumulator, then it will go to memory. So, and this accumulator is of 8-bit. And other registers are also there. B, C, HL, and a lot more registers are there, but all are of 8 bits. So you can do only 8-bit processing. So 8085 is a 8-bit general purpose processor. Okay. What are the total number of pins in 8085 microprocessor? Right. There are total 40 pins in the 8085 microprocessor. So you see the pin diagram. There are total 40 pins. So we have, uh, if you see the pin diagram, we have this X1 and I don't know what this number is. Maybe it's 3. Whatever. These are the frequency generators where we uh, connect the frequency generators output. Then we have some reset. So these all are uh, see these are interrupt signals. These are like the hardware interrupts where we can tell the processor to stop or do something, some operation. These are the multiplexed address and data bus. That means these both of all these eight. So these are eight thing AD0 till AD7. So when required, this will work as address line, and when required, these will work as data lines. Rest we have total 16-bit address lines in. So and 8-bit data lines. So we have, let's say, AD0 to AD7. Then we have A8 to A15. So it is like 16-bit of address and 8-bit of data. Data is multiplexed in the first 8 bits of address lines. Then some uh, control options, enable, read, write, and everything. Output log, reset, some delay, and the power supply pins. So they are total 40 pins, 1 to 40. Okay, so next question. What is the purpose of ALU in 8085 microprocessor? Okay, so it is to perform mathematical operations. These two are both done by the control unit. Maybe we'll talk more about it in the coming sessions. Data is stored in temporary data is stored in registers. So ALU is just used to perform mathematical operations. Next one. What is the data bus width of 8085 microprocessor? So we just saw this. It is 8 bits, right? We just saw AD0 to AD7. Then we have A8 to A15. So we have 16-bit address or your 16 address line and 8-bit data. Next, which of the following machine cycle is not present in the 3-cycle instruction execution? Sorry, I think I lost connection. I will connect again. Okay, so the last question that we were discussing was which of the following machine cycle is not present in the three instruction execution model? Right, this is encode is not there, right? Whenever we have to process something in ALU, is accumulator from memory. So instruction is written in some part of this memory. We bring this instruction in the accumulator. Then we decode it and execute it. So it is always fetch, decode, and execute. So encode is not there. Okay. Last question that I have for today is 8085 microprocessor can operate with dash clock. Okay, so I'm not sure if this was in the videos or not, but the answer is 3 megahertz. So 8085 can actually operate between 3 megahertz to 6 megahertz. This is the operating clock frequency range for 8085. So answer is option A. So this was the last question for today. In the next week, we will see more questions, mainly related on the instructions in 8085. So what instructions performs what operations, that we'll see next week. So it may be possible that I may shift uh, next week's Tuesday session to maybe Monday or some other day. It will be announced to you guys. So please keep an eye for that. I will let you know that. Okay. Are there any doubts? Sir, can you please explain what is duty cycle? Sure. So in very simple layman terms, let us say you have a square wave signal. Fine. Now, now let's say this signal is, let's say S1. Now, if you can see the time period of the signal is, let's say this time T1. Now, what is the time period where it is on? Let's say this T1 by 2. This is also T1 by 2. off time and on time. So basically duty cycle is T on by T on plus T off, or it can also be written as T on by time period. So for this signal, duty cycle is 50%. Let me draw another example signal where duty cycle is somewhat different. So maybe this is the signal. So again, if you see, time period is this, right? So let this time period be, let's say, for 4 nanoseconds. But you can see the on period here is only 1 nanosecond. It is off for 3 nanoseconds. So your duty cycle is T on by T on plus T off, which is 1 nanosecond by 1 plus 3 is 25%, right? Or it will be 0.25 actually. So duty cycle for this signal is 25%. Is it clear, Harsha? Okay. So duty cycle very simply just means T on by T on plus T off. Okay. Is there any other doubt? Okay, then I'll close the session. We will meet next week. Next week, the session, if I'm not going to take on Tuesday, I'll announce on the, like, it will be announced by the NPTEL team in your emails. Yeah. Thank you, guys. Bye.